So this was a 0. So 1 minus 1 goes to 0. 1 minus 0 is 1. 0 minus a minus 1 is a 1. And 2200 minus 600 is 60. And then, well, this is 0, 0. Well, that's, yeah, so that's not changing. So actually, we're not doing this. Okay, so we've got what? One more to go, right? Because we got to do row 4 minus row 3. So that's going to go to
wouldn't it have to be like row 3 times?
Oops, 0, 0 minus 1, 600. So this all goes to 0. So we have more, okay, that's why, because we have more unknowns than we have equations, right? Because these two are unknowns. So we can pick a value for one of them and solve for the other and work it that way. Does that make sense? Everybody's totally confused.
But you wouldn't be able to pick a value for all three and get the same solution.
So I did it the way we did it the first way,
Yeah.
and I got all the way down to the same thing too. I just got 2x4 equals 0.
Okay, yeah.
So does that mean that it's an infinite number?
Wait, 2x4 equals 0. Well, you can still solve for x.
Well, so x4 equals 0 then.
Okay, yeah. Oh, right. So yeah, your fourth unknown is equal to 0, and so it's you.
I don't think it is. It should be equal to. It would be equal to 0 if there was a 1 in that for x4. But x4 is undefined.
Yeah, because we did that the last, right?
Mm-hmm.
That's why there's infinite solutions. X4 is
Because you don't have a known you don't have one singular value that you can plug in for x4 to produce a solution for 3, 2, and 1. I'll get a better definition and get you some better examples. But I don't want you guys to get too sidetracked with this. I mean, we need to go through this. I want you to understand it enough so that you get what's going on in the black box, because that's important. But it's the point of this class is not to make you linear algebra experts, right? They have a math class for that. I want to make you experts in applying finite element analysis and knowing which element to use in the correct scenario to produce a result that you can drive, converge towards a solution or an approximate solution, right? That's the important thing. But to just have you, I guess, pull levers on the black box and see what comes out and try to guess what's happening and learn or try to learn by pulling this lever and seeing what's happening and then pulling these two levers and seeing what's happening is not what I want. I want you to have a better understanding of what's happening so that you know which lever to pull and when. So if that analogy makes sense. Okay, so I will get the lab posted, and it has to do with anisotropic materials, right? So you'll just have to look up and find some and go from there. But so we won't have class on Monday because it's a holiday, and we'll get into, so the reason we're going through some of this is because we're going to apply this Gaussian elimination to what we're doing in chapter 1 when we meet next Wednesday. I'll start going through the spring element example that he has in the chapter. But I wanted you to at least see some of that stuff before we started this example, and then now for Wednesday we'll go through all that stuff. And we'll do some of the homework at the end and that sort of thing. Okay? Makes sense? So I'll get you the lab, you can work on the lab, and then we'll talk about that on Wednesday, and we'll go through the spring elements in chapter 1 on Tuesday as well, and I'll assign you some homework related to that. I don't know, and I might give you some simple matrix stuff to practice before then. A couple problems. Okay?